one last little concept in this chapter, and that's the concept of what we call polarization. Light from the sun is what we call unpolarized, meaning the electric field portion of the waves can be oscillating in any direction at all. It could be oscillating up and down, which means the magnetic field would be oscillating back and forth. The electric field could be oscillating back and forth, which means the magnetic field would be up and down. It could be off at some random angle. So the electric field portion can be in any direction. That's what we mean by unpolarized light. Light from our light bulbs is unpolarized. It is possible, though, to take light and polarize it. To polarize light means all of the electric field is in one direction and one direction only. It doesn't specify which direction. The electric field could be, say, up or down, or it could be side to side, or at some angle. It could be at any angle. Having polarized light just means that your electric field of your wave is moving in one direction and one direction only. Okay? Turns out when light reflects off of surfaces, it becomes mostly polarized. Not completely, but at least partially polarized. For example, light reflecting off of water the reflection is polarized. So you can buy polarizing sunglasses, and those polarizing sunglasses, basically, it's a filter. Looks kind of like this, only prettier. It's a filter that when the light shines on it, it will not allow certain directions to go through. It will only allow a certain direction to go through. Basically, what a polarized film is made of is a whole bunch of carbon chains that are parallel to each other. When the light comes in, any of the light oriented in the same direction as the polarizing film gets absorbed. It doesn't pass through. Any light that's perpendicular to the chains goes straight through and without any problem. So when we talk about a polarizing filter, the axis, so here's our filter. If we say the axis of our filter in this case is horizontal, that means any horizontal pieces of the electromagnetic wave will make it through. Anything that's perpendicular to this will not make it through. Okay? Whenever you shine unpolarized light on a filter, you always lose half of the intensity. It always cuts out half the light. And that's because all of these vectors can be broken down into components that are simply vertical or horizontal. This filter will cut out all vertical components and only allow the horizontal components through. The resulting light is oriented in the same direction as the filter. Okay? If I take polarized light and shine it on a filter, how much makes it through depends upon the angle between the two filters. So I have two filters here. Right now they are oriented so that their axes are in the same direction, so that doesn't cut much light to overlap them. Cuts a little bit, but not a whole lot. But if I change the orientation, so right now they're both in the same direction. If I change the orientation, if I change the angle between their axes, less and less light makes it through. If I make their axes perfectly perpendicular, it won't let any light through. So as I change it, change the angle, it gets darker and darker. When they're actually perpendicular, it will be perfectly black, and it will cut out all the light. We have a simple equation that describes how much light will come through. It looks like this. the intensity of the light that comes through is equal to the original intensity of the light that's hitting the filter times the cosine squared of the angle that's between the light and the filter. So if our other filter, let's say we had this horizontal polarized light, this is polarized now. Let's say we shined it on a filter that was at an angle. The theta in this equation is the angle between this, the polarized light, and this, the axis of the filter. So that is theta. Okay. The bigger theta gets, the closer the cosine theta term gets to 0. So less and less light will make it through. Now, polarizing sunglasses are great because they do reduce glare. If any of you fish, I'm sure you love your polarizing sunglasses if you have them, because the light reflecting off the water is polarized. If you're wearing polarizing sunglasses, the filter is oriented in just the right way that it's perpendicular to that polarized light, and it blocks out all of the light that's polarized. So basically, it blocks out the glare from off the top of the water. And you can see into the water, and you can see what you're looking for, assuming the water's not all muddy and gross, of course. You can buy, if you have a nice camera, you can buy polarizing filters for your camera as well to reduce glare off of and reflections off of different objects.